Yes, good morning. So this time, let's have now another special right triangle, which is the 30, 60, 90. Okay, 30, 60, 90 special right triangle. Okay, so for this lesson, we are going to find the measure of the sides of this triangle. Now, how are we going to solve this? It's like this. Say, for example, we'll have this triangle. Okay. Now, this triangle has the measure. This is 90. This is 30. While here, this is your 60. Ouch, I cannot type. So, this is 60. Now, if you do remember, the opposite of your 90-degree angle, that is what we call the hypotenuse. At the same time, this is the longest side because it's the opposite side of the largest angle. In our Pythagorean theorem, we call this one, or we have this one as our C. And again, this is our A, if we do recall, and this is our B. Our A here is the opposite of 60, while B is the opposite of our 30. Right? Now, let's forget this A and B for a moment. Let's recall that later. Okay, now, here, how are we going to find the measure of the sides now of this 30, 60, 90? Now, I'll give you another triangle and ouch, okay, let me use another color here. Say this one. Okay, and let me adjust this one. Okay, say here. Okay, for a while I'm trying to fit my original triangle to this triangle. Okay, here. While. Okay, now here you go. So as you can see, I have already two triangles here, a black triangle and a yellow triangle. This yellow triangle is actually an equilateral and equiangular triangle. So since this is an equiangular triangle, each angle here measures the same. So if this is 30, okay, if this is 30 here, therefore this angle also measures 30, right? And 30 plus 30, that is 60, correct? Of course, this is 60. Now this is also 60, right? Okay, because this is 60, another 60, so to equate it into 180, so that is 60 as well, and that is why this is called an equiangular triangle. Now if you do remember as well, if this is now this is a line drawn from the vertex, one of the vertices of the triangle, which is perpendicular. Since this is perpendicular, this measures 90 as well. Now, the opposite side of our 90-degree angle is what? Yes, this is our H. So, this is our H. Now, if we're going to check that in our yellow triangle, the bigger one, okay, here, this side, which is our H, is the opposite side of our 60, right? Same thing here. This is also opposite to our 60, correct? So, if this is 60, this angle here measures 60, Okay. Therefore, what's the measure of this side? Or what do you call of this what do you call with this side? Okay. So this side is also h, because this side is h, which is the opposite of 60, and also this side here, which is our h, which is also opposite of our 60, right? So, if we're going to go back to our original triangle here, okay, well, let me use the original color as well. Say this one, and this measures again. This is our right angle. This is our 30. This is our 60 degree angle. Okay. And this is our H. So again, this is our A. This is our B, right? Now, what is the measure of our B? Now, if we're going to check our B to this concept, B here is 1/2, right? 1/2 of our H. So we have now the measure of our B. Our problem this time is our A. So for us to find our A, let's recall or let's use the concept of our Pythagorean theorem, which is C squared is equal to A squared plus B squared. Oh, sorry, plus B squared. So this is our Pythagorean theorem. And so for us to solve our A, so remember our C is our H, right? So instead of writing C, this is H, which is equal to A squared plus B squared. And from here, okay, from here, we have the value of our B. So instead of writing B squared there, so we will have the value of B. So this is H squared is equal to A squared plus, okay, the square of our B, which is 1/2 of H. So from this, we will simplify the equation. This is H squared is equal to A squared plus 1/4 of H squared. Now since we have H here, H squared and another H squared, 1/4 H squared, so let's combine the like terms. Okay, let's transfer 1/4 H squared here using the additive inverse. So then this is now H squared minus 1/4 H squared, which is equal to our A squared. So let's simplify then. Okay, so this is 1 minus 1/4 of H squared, which is equal to A squared. So how much is 1 minus 1/4? 1 minus 1/4, this is 3/4, right? So this is 3/4 H squared, which is equal to A squared. Now for us to find A, so let's enclose this in a square root. Okay, so this is now square root of A squared, and this is also the square root of 3/4 H squared. So this will be cancelled. Here, this will be cancelled as well. So we will have now A here. A is equal to the square root. Oh, sorry. Okay. A here A here is equal to the square root, of 3 times h all over 2, because the square root of 4 is 2. Wow! So we have now the value of a, which is the square root of 3 times h all over 2, the value of b, which is 1 half of h, and of course h. Now our 30, 60, 90 is already complete. We have the measures of the sides as well as the measure of the angles. So let's try to solve some problems. Say here. Okay, well, let's use another color for our triangle. Say here. Now again, this angle here measures 90. This is 30. Okay. This is 60. Now say for example our h here is 8. Okay. So we'll try to solve first b. So b here, which is equal to 1 half of your h. What is your h? Which your h is 8. So 1 half, okay, 1 half of 8. How much is 1 half of 8? Half of 8 is 4. Correct. Very good. So easy, right? So you have now the value of your b. So we need one more side, which is our a. So a here, this is the square root of 3 times your h. Your h again is 8. Okay. Which is all over by the denominator here is 2. Now 8 divided by 2 is 4, right? Therefore, a here is equal to 4. Okay, 4 and the square root, ouch, I'm sorry, 4 and the square root of 3. Wow! I guess you were able to you can find the measure of the sides here easily. I hope you enjoy this video and you learn so much from this. Good luck to our next discussion. Thank you for watching. See you next time. Bye for now.